Welcome to lesson 137, rational and irrational numbers. Today we're going to talk about how to identify rational numbers and how to identify irrational numbers. All right, so when we talk about numbers, there's actually all different kinds of numbers, and we're going to kind of show you here where each of them fits. So our first set of numbers that we're going to talk about all fit in this circle, and in this circle there are what we call rational numbers. Okay, we'll define this for you in a little bit. But you need to know that every number, so everything that's inside of this circle is a rational number. Then inside of that, there are numbers that are rational, but then there are also numbers that are not rational, but they are still integers. Okay, we talked about integers a little while ago. So we have rational numbers and then integers. So all integers are rational numbers because they fit inside of the criteria for rational numbers, but not all rational numbers are integers. So like pi, oh, I'm sorry, not pi, repeating decimal. So 1/3 as a repeating decimal or 2/3. They're rational numbers, but they're not integers because we know that integers are numbers without fractions or without decimals, and they can be positive or negative. So rational numbers as well can be positive or negative. However, they can also be decimals and fractions. Okay, and then inside of that integers category, we know that we have whole numbers. Now, whole numbers also do not have decimals or fractions, but they also can only be positive. So if we want to make a couple of notes in here, we can say no decimals, no fractions, and we can say yes to positive and yes to negative. And then for whole numbers, let's just make one big list of no, so no fractions, no decimals, and no negatives. And yes, it can be positive. Now, rational numbers say yes to many things. So they can be positive, they can be negative, they can be fractions, and they can be decimals. But now the thing is, they have to be a terminating decimal or a repeating decimal to fit in rational numbers. So if you want to put in here somewhere terminating, repeating, just to remind yourself, that would probably be helpful. All right, so we can talk about the definition of rational versus irrational numbers because we also have what we know as irrational numbers that are off in a world all by themselves over here. Irrational numbers are numbers that are not rational. They are also not integers, not whole numbers. They are only going to be fractions and decimals. So over here, all by its lonesome, we have irrational numbers. Okay, and this is where we have numbers like pi or the square root of 5, because the square root of, and remember, square root talks about if you have 2 squared equals 4, because 2 times 2 is 4, or 10 squared equals 100. So then the square root of 100 would equal 10. And we'll get more into square roots later on. However, so you have an idea, numbers that are not perfect squares, or numbers that turn into a decimal that goes on forever but does not repeat, are all considered irrational numbers. Okay, so in looking at these numbers, I want you to take a second and look, and I want you to determine if you think they're irrational or rational numbers just based on what we just talked about. When you come back, we'll go over your answers. All right, so this number right here is actually what we know as pi. If you did not recognize that, that's okay. But you can see here with the ellipses at the end that this goes on forever. And you can see from the numbers in front, there is no pattern. 1, 4, 1, 5, 9, 2, 6, 5. There's nothing that repeats, which makes this an irrational number. The square root of 3. So if you're unsure of what the square root of 3 is, we can go to our tools and use a calculator. Okay, and I want to find the square root of 3. Or I'm sorry, square root of 3. Okay. And here it tells me it's 1.732051. Now my calculator is going to round off. So the calculator really isn't ever going to show you that something goes on forever. Okay, but if I take the ratio for pi, it also stops pi here. It rounds it off. So you have to be able to tell when your calculator is rounding something, but since you don't see anything repeating, we can tell that this is also an irrational number because it goes on forever and does not repeat. 6 does not go on forever, does not repeat. It's actually just a nice whole number and integer, so it is also a rational number. And 0 and 645 thousandths repeating. You can see here it goes 645, 645, 645. Since you see the ellipses here and you see the pattern in front, even without the line above, this number does repeat, so it is considered a rational number. Okay, it can be expressed as a ratio. 0 and 7 thousandths, again, terminates, so it is a rational number. The square root of 2, again, if you plug it into your calculator, goes on forever, so it is irrational. 0 and 6/10 repeating, since it repeats, even though it goes on forever, since it repeats, it is considered a rational number. -1 and 25 hundredths is a rational number. It has a terminating decimal, so it is rational. 6/7 has a terminating decimal, so it is rational. 0 is just 0, but it is a rational number because it is also an integer. 2/3 goes on forever. However, it repeats, so it is a rational number. I want you to be careful though, because when you use a calculator to look at 2/3 as a decimal, you'll notice that it rounds up to 7 here. That's because the 6 repeats forever, but our calculator can't show numbers forever and ever and ever. The screen isn't large enough, so we have to see that since these do repeat, you have to understand and assume that it is because the 6 that would be here is telling the other 6 to go up to a 7. So we have to know these numbers by heart, knowing that 2/3 is 0 and 6/10 repeating, because a calculator isn't always going to make that so easy for us. And then the square root of 25, when you plug it into a calculator, or if you know that 5 times 5 is 25, you know the square root of 25 is 5. Okay, so based on what we're learning here, you've heard me say a lot, terminating, repeating, decimals. Anything that is an integer or a whole number is rational. Anything that has a terminating decimal or a repeating decimal is rational. Anything that goes on forever, does not repeat, is irrational. So if it just goes on forever in a random order, it's an irrational number. So to go on definitions, a rational number is a number that can be written as a ratio of two integers. As a decimal, it either repeats or terminates. Okay, and in your example, I would actually like you to put a couple of examples. I want you to put the square root of 25. I would like you to put 2/3. I would like you to put 0 and 1/10 repeating. Okay, and then I'd also like you to put a -4 and a +1 and 25 hundredths, just so you can see all the different variations of numbers here. Okay, and then an irrational number is a number that can't be written as a ratio of two integers. As a decimal, it neither repeats nor terminates. Okay, so we talked about these numbers. They go on forever and ever and don't end and do not repeat. So in this case, you can put the square root of 2, and then you can make up your own decimal, but it can't repeat anything. and you can use the ellipses. Typically you'll see these ellipses, which tells you that this goes on forever. And since you can look in front and see that there's no pattern, you can know that this is not a repeating decimal. All right, so I'm going to put up the next slide, and I'm going to ask again that you sort each of them into rational versus irrational. Okay, and when you come back into class, we are going to be discussing rational versus irrational, and you need to be ready to defend your answers. So while you're doing this, I want you to think of how you would defend why is it rational, why is it irrational. All right, so here are your set of cards. I want you to pause, take your time, put them into groups of irrational and rational, and when you come back, we'll go over your answers. All right, so this is what you should have come up with. You have 35, the square root of 81, 7 and 444 thousandths, 87 hundredths repeating, negative 2/3, 0 and 8 hundredths, the square root of 169, 15 hundredths repeating, negative 1,000,000, 0, 1/4, and negative 15 and 37 hundredths are all rational. The square root of 5, 2 and 7, 1, 8, 2, 8, 1, 8, 2, 8, 4, 5, 9, 0, and so on and so on. Negative 5, decimal 6, 8, 3, 4, 0, 1, 3, 2, and so on and so on. And the square root of 42 are all irrational because they all go on forever. All right, so in your notes, I want you to please make sure that you have anything written in here that helps you know the difference between rational and irrational numbers. Make sure that you have the definition of rational and irrational numbers, that you have your two different sorts, and then in Edmodo you have your quiz, and I'd like you to answer these following questions. As always, if you have any questions, please be sure to post them in Edmodo so we can go over them in class.